Equal vectors. The vectors are usually independent of position. A vector could be anywhere and still be the same. Vector u, vector v, vector t. These three vectors represent the same movement, so they are equal. The same vector can be at many places on the grid. A negative vector has the same magnitude, but the opposite direction. Vector minus a is the same as traveling backwards down the vector a. Vectors arithmetic, multiplying vectors by a scalar. Don't be afraid with the word scalar. It just means a number. To multiply a column vector by a scalar, we multiply both values, the horizontal and vertical, in the vector by that number. To get 3 times d, we must multiply both values in the vector by 3. When we multiply vectors by a scalar positive number, the vectors change the size, but not the direction. Example 1. If u is minus 4 and 2, find 2 times u. To get 2 times u, we must multiply both values by 2. Now, let's make the same. Let's multiply u by minus 3. We multiply both values by minus 3. You should notice that when we multiply vector by a negative number, the vector changes the direction. Addition of vectors. To add two vectors, we add the x values and y values of the vectors. Let's find the vector t. Vector t is u plus v. Let's add the x values and y values of the vectors. We can represent geometrically the addition of two vectors by drawing the first vector, then starting the second vector where the first vector ends. Draw the vector t from the initial point of the first vector u to the terminal point of the last vector v. The single vector created by addition is called resultant. When you add two vectors, you must draw the first vector, then starting the second vector where the first vector ends. Example 1. Draw the vector u and vector v. Find the vector u plus v. Where the first vector ends, the second vector starts. Add the corresponding x and y values. Draw the resultant. Find the vector u minus vector v. Add the corresponding x and y values. Where the first vector ends, the second vector starts. Draw the resultant. Find 2 times vector u plus 3 times vector v. We will make the same. Draw the resultant. Example 2. In the parallelogram below, vector BA is 2 times vector u. The vector BC is vector v. M is the midpoint of CD, and N is the midpoint of AD. Draw the vector BA. The vector BA is 2 times vector u. The vector BC is the vector v. Find, in terms of vector u and vector v, the vector AC. We want a vector that starts at A and ends at C. AC is AD plus DC. The vector AD is the vector V. Adding the negative of the vector CD is the same as adding the vector DC. Vector DC is minus 2 times vector u. Find, in terms of vector u and vector v, the vector Bm. We want a vector that starts at B and ends at M. Vector Cm is a half the vector Cd. Find, in terms of vector u and vector v, the vector mn. We want a vector that starts at m and ends at n. Mn is md plus dn. Md is a half Cd. Dn is a half dA. Position vector. Position vector is a vector that indicates the position of a point in a coordinate system. It always starts from origin O. The coordinates of a point and its position vector are the same, so every point in the coordinate system can be represented by its position vector. Point A, vector OA. Point B, position vector OB. Point C, position vector OC. Point D, position vector OD. Example. If A is point 2, 3, B is point minus 2, 4, and C is point 5, minus 4, find the vector AB. Let's draw the vector OA in the vector OB. We want a vector that starts at A and ends at C. AB is AO plus OB. AO is minus OA. Let's draw the vector AO. Remember, where the first vector ends, the second vector starts. Find the vector CA. Draw the position vector OC. The vector CA is the vector CO plus the vector OA. We want a vector that starts at C and ends at A. Find the vector BC. We want a vector that starts at B and ends at C.